Connie Huffa, and welcome to Fab Design Studio. Bruce and I would like to thank you guys for signing up to our Thinkific program. We put together a few mini courses for people to get a flavor of what this technology actually entails. So this particular class is about technical textiles versus traditional product development. Now, contrary to what a lot of people believe, things don't always happen as quickly as we want them to. And technical textiles have quite a few more challenges depending on the industry, the regulations, the auditing, and several other things, including some of the supply chain issues. So in this particular class, we're going to compare and contrast and show you some of the pretty interesting tips to explain some of the basics and some of the frequently asked questions that we get all the time about the industry, about machinery, about development. This is an introductory class, and if you'd like to know more, we will have more in the design track of the Learn with Leaders program. We'll hope you join us. Only 2 to 4% of all knitting machines sold in the world, regardless of brand, are purchased for technical textile manufacturing. Manufacturing such products as medical products, aerospace, automotive, military projects, smart textiles, footwear uppers, home and office seating, geotextiles, architectural projects, marine projects, sporting goods, compression products, other industrial products, on-demand manufacturing, and customized manufacturing formats. This means that the majority of all machines are sold for manufacturing traditional products, such as apparel, apparel accessories, and home furnishings. In attempting to discuss technical machine parameters and matching materials with feed devices that manage yarns and materials in the knitting process for particular products, it would seem prudent to briefly discuss the developing products in a traditional knitted textile approach as compared and contrasted to a technical textile or innovative approach. We will talk more in detail about costing in the design track of the Fab Designs Learning with Leaders program. Traditional products typically use off-the-shelf or standard OEM machine builder machinery with general factory presets and standard specifications for needles, sinkers, feeders, and yarn management. In developing technical textiles, there are many small incremental adjustments that need to be made over the course of the development process to stock machines. These incremental changes to machine settings, programming, feed systems, and timing of the knitting process itself are developed specific to the type of textile fabric, product, or component being made. Additionally, the specification of the raw material being used may be modified on a polymer, fiber structure, and yarn construction level. Many specifications in machinery, materials, and after processes take on configurations which are proprietary and specific to the end product, rather than using stock machine with general presets and stock materials. Developing technical textiles follows a development path which usually involves legal, engineering, testing, environmental, health and safety, stage and gate elements, which the traditional product development path does not use, need, or in most cases even is aware of. The technical development path mitigates risks and challenges in the design and manufacturing process, benchmarking standards of the raw materials, fabrics, and the products themselves to substantiate quality, legal, and performance claims. The substantiation of these attributes differentiates the product in the marketplace and is typically the basis for the intellectual property, IP. Apparel products, home furnishings and accessories traditionally employ a rapid development process where most of the elements that go into a product produced at the traditional manufacturing facility are already known in advance: materials, equipment, and labor. These products are designed and built to establish assembly parameters and cost structures and are marketed by the client to slot into the factory's seasonal or quarterly production calendar. In the apparel world, their traditional product development timeline is typically 3 to 6 months from the factory receiving a design brief to production. This is after a designer may have already spent 3 to 6 months researching trends, shopping materials, competitors, and technology, and then distilling mountains of research down to getting a concise design brief. A design brief represents a tremendous amount of effort in pulling together a product and marketing research by the designer, brand, or startup, who are relying on the briefs being interpreted correctly and promptly by the factory, resulting in a situation where they will be rewarded by their own projected sales and revenue of their product. Once a designer has created her or his design brief, the designs are turned over to the factory's operations staff, including the knitting programmer, who then creates a first proof of sample based on the original design brief, which typically includes color references, desired materials, stitch references or a stitch map, cutting patterns, inspirational references, competitive references, price point, positioning, and placement references. The operations department of a traditional factory is concerned with translating portions of this conceptual information into clear directions to make tangible goods the customer will accept at a fair price that the factory is comfortable with to assure profit. Color references are to understand lead times and any custom dye needs. Desired materials are to assemble vendors and foresee production issues. Cutting patterns are to understand assembly requirements and standard action minutes. Inspirational references are to understand expectations and deliverables. Competitive references are to understand design complexity and pricing. Price point, positioning, and placement references are self-explanatory in that the customer wants to know where they're going to be placed in the market and what price points they need to meet or hit. This traditional knit apparel design development path uses the types of yarns which are geared to mass market, designer, and better markets, and which fit into the normal and customary business model and business plans of the knitting factory. The factory has an existing platform of manufacturing, and all the products each representative factory produces fit the existing production equipment. This platform budgets knitting time, labor, administrative overhead, and materials annually and quarterly, so that adequate resources can be allocated for the development process and flow of production through the factory. This may include taking knitting machinery and sewing staff out of production to make samples, cost of sample materials, and the programmers and sample staff's time to produce an expected number of effective design programs per quarter. Besides making the samples, the factory is also simultaneously producing their previous quarter's projected amount of production of products, which is the factory's return on investment, their ROI, for their past development resource investments. The materials that designers typically use and factories accept are usually off-the-shelf materials from apparel yarn suppliers around the world. These suppliers produce variations in color and texture every year, but the yarns have predictable or rather common expectations for development and production on specific gauges of machinery. Yarn producers may produce custom colors or blends for the designers, but for the most part, these yarns are designed for the existing manufacturing capabilities and expected to run on the basic off-the-shelf machinery with no extra effort other than perhaps some waxing. The knit programmer and the factory do not expect any surprises in the knitting times, handling the materials, or finishing of the fabric or products. If there are significant problems in running the yarn, the yarn supplier could very well expect to get the material returned by the factory. It is true that not every idea makes it to a design brief and that not every sample is a success. A factory may develop samples for designers, brands, and startups that may not turn into business for the factory or their customers for many reasons. Yarn may be late, samples may be canceled, or not meet management's criteria to take the product to market, or a designer, brand, or startup may sample at multiple factories around the world and then choose the least expensive factory to replicate the best product sample. Things happen all the time in this competitive industry, yet each quarter, every factory's success depends on a healthy percentage of these samples to turn into enough production projects to fill their production capacity for the following quarter on machinery they already own. With manufacturing consolidation offshore, there are fewer places for designers, startups, and brands to manufacture. And many times, when working with companies so far away, designers, brands, and startups cannot be sure that their products are not shown to their competitors or that versions of their ideas are not manufactured and brought to the market before their own products. Unless a designer, brand, or startup is big enough to buy up the interest of the factory working with competitors, keeping control of manufacturing at its products is not guaranteed. Even the biggest brands in the world have issues with knockoffs and spend considerable amounts of time, resources, and capital chasing copycats. Most brands today's marketplace focus their energy and resources on cultivating freshness of designs, marketing products, keeping manufacturing costs down, and scouting new materials and exclusives. There is more to what brands actually do, but for the brevity of this segment, a limited amount of activities is presented. The overseas manufacturing partner has become the source of technical information on materials, fabrics, and methods of manufacturing. The designers, brands, and startups have become the manufacturers of record as noted on import manifests without actually performing the manufacturing. Factories and machine builders have always made swatch samples to demonstrate their capabilities, but today, factories and machine builders are now expected to come up with fresh ideas, new technology, materials, stitch techniques, entire garments, lines of products, and even the manufacturing knitting data for designers, brands, and startups to reference and adopt as their own. For example, Colin Shaw, the Intuitive Consumer Podcast, states, organizations need to offer customers breakthrough products, services, and solutions to effectively compete in today's innovation-hungry economy. The challenge is customers often don't know precisely what they want. I agree with him. Another example, the Shimaseiki user site contains more than 10,000 original knit samples, while additional samples are added every month. Users can view and download images and purchase knitting data as well. It's a really good site. The trend collection, materialization, overcoming the resistance of material represents the biggest obstacle in the creation and production of textiles. The latest Stoll collection reflects on this challenge, highlighting how versatile Stoll machines handle complicated materials of all kinds. And I have the sites for each one of these. You can click the links. Companies who make consumer products and fashionable apparel live and die with trends. In 3 to 6 months, the factory designers, brands, and startups are usually onto something else, from their product pipeline or tweaking the colors and cut to release the best sellers. But product is essentially made to the manufacturing capabilities, timelines, and budgets of the apparel factory. Technical textiles, on the other hand, follow a very different path of development from idea to production that takes on average 12 to 18 months, and some industries it may take 3 or more years of development. Most technical textiles involve intellectual property of one sort or another and testing of the materials, products, and the manufacturing process itself. Product testing for many technical products may take 6 months to a year or more. Most technical projects evolve and grow the intellectual property over the course of the development process. A project's time frame depends on the particular industry, regulations, auditing requirements, and the risks a product, raw material, or process poses. The investments in research and development, R&D, in materials, design and technology, machinery, specifications, and stitch combinations far surpasses a typical 3 to 6 month apparel project. The ROI for technical development is amortized over the 5, 10, or more years that a product lifecycle lasts for the organization. Most times the product lifecycle lasts the length of a patent, 25 years. Each type of knitted textile requires precise handling and dosing of materials and precision layout of knitted loop structures. Anything that can affect raw material quality or degradation is reviewed, from transport to warehousing practices, FIFO, first in, first out, planning and optimization of efficient rates and consumption. This could be Lean, Six Sigma, Kanban, just a few. Not only the manufacturing facility, but throughout the entire supply chain, which likely includes audits of vendor practices and MSDS scrutiny. Material safety data sheets. The knitting environment, machine maintenance, and calibration practices are also part of the manufacturing specification. Documentation and validation of the knitting process and resulting fabrics needs much more careful attention to replicate consistently. Some technical textiles, for example, footwear uppers, may be made from custom extrusions or off-the-shelf base materials, such as polyester, nylon, or natural fibers. Most technical fabrics include one or more performance materials in a critical support structure function, such as elastics, coarse-spun lycra, thermoplastic materials, specialized fibers such as Kevlar, ultra-high molecular weight polyethylene, Nomex, slick filament Teflon, base materials such as nylon, polyester, or natural fibers with special cross-sections, carbon fiber, fiberglass, ceramics, specialized metal alloys, basalt, tungsten, conductive materials, wire, monofilament, cord, braids, and other engineered materials. These materials require special feed devices to manage them and feed them into the machinery at speeds, tensions, and proportions which can be defined, measured, analyzed, improved, and controlled to achieve an acceptable rate of consistency. All technical projects are built from the fiber content and structure upward. Despite what many machine builders market, technical textiles are a commitment and a long-term investment in forward-thinking people with new skill sets, adaptive technology, materials development, and change of culture in both big picture way of thinking and a detailed quality assurance and quality control in producing for the life cycle of a specific product, which is usually a first to market product. If technical textiles were easy to develop and program and made on the same general issue stock machinery with off-the-shelf yarns, every company in the world would be making them so inexpensively with no intellectual property that there would be no market worth pursuing. Each technical product is as unique as the mindset of the team creating it. The holy grail today is game-changing innovation. The reality is that a designer, brand, team, or startup does not wake up one day and just create complex technical textiles that change markets and create intellectual property without moving out of their own comfort zone and being committed to changing the way they've always done things in the past. There's a process, and it's all off-road driving, going places no one has traveled previously. Rarely can innovation happen using all the same off-the-shelf elements. The same structure, stock machinery and stock manufacturing processes, the same fuel, the same stock materials, the same internal knowledge, existing in-house staff and skill sets, existing external knowledge, existing manufacturing skills. Their same existing culture, the same staff still afraid to fail, the same behavior, management's focus on costs rather than exploration of ideas. At least two things in this equation need to change for fresh ideas to take place. All six need to change to bring about positive change and increase the chances of innovation actually happening. Developing technical textiles is a journey, and the first step is moving out of the comfort zone to take on completely new perspective. and being open to feeling one's way around a new manufacturing platform that requires making small, incremental, educated changes to champion a new mindset about machinery, materials, growing new skills, and exploring ideas. This is a quote from Safi Bahcall from the Innovation Equation, Harvard Business Review, April 2019. There's a certain size at which human groups shift from embracing radical ideas to squashing them. When employees feel they have more to gain from the group's collective output, that's where they invest their energy. When they feel their greatest rewards come from moving up the corporate ladder, they stop taking chances on risky new ideas whose failure could harm their careers. I would suggest you really read this article. It was excellent. Garment factories which are set in their ways and their business models are not good candidates for manufacturing technical textiles nor being manufacturing partners. They do not like change, nor the unknown, and they grow impatient after the development norm of 3 to 6 months. Few are willing to experiment with projects that are outside their business model for as long as a technical textile product takes to develop. Designers, brands, and startups who expect to create technical textiles in 3 to 6 months with the same traditional business model and development path as an apparel and consumer product manufacturing are also not good candidates for developing technical textiles. In every technical project, a designer, developer, brand, startup, or team starts out with what they already know. They research and define where they want to be, but they're not quite sure of the path to get where they want to be yet. In order to truly innovate, designers, brands, teams, and startups need to leave the mindset of doing what's safe behind. They need to have the courage to fail. They need to be open to learn new skills and knowledge that inspire them and their teams. They need to be comfortable in new knowledge to push manufacturing capabilities. They need to focus on the goal and not get caught up in the technology. They need to understand when to say no to tangent development. They need to think long-term and not burn bridges with mentors once knowledge has been transferred. The first step from the ordinary knowledge that a team already has and into the road of exploration and adventure toward innovation is to first find where the special knowledge, skills, and help required to go forward actually exist in order to move forward in the direction of a team's goals and enlist help and mentors. Traditional product development requires about 40% of the planning to be completed before a sample is ever made, including knit apparel. In developing technical textiles, the designer, brand, and team are designing the product, developing the fabric, and building the machine specification simultaneously with their mentors and many times alongside the machine builders and yarn suppliers. As their first step, one does not buy just any kind of knitting machine a machine builder has in the showroom and expect it to make all types and variations of technical projects. The machine specification evolves with the experimentations of the project, specific manufacturing platform, supply chain, tooling, as skills and knowledge are learned. There are always obstacles to every project, whether traditional or technical. Naysayers and Monday morning quarterbacks, people who are afraid to fail, those who are overly cautious and sideline projects, rigid thinking, over-testing projects' viability at the wrong points along the way because that's how it always was done. Conservative accountants and attorneys trying to guide the project back to known ways of doing things with known materials, known costs, and foreseeable risks, or kill it altogether. Overzealous machine salespeople who, once they sense there's a viable sale in this project, they want a quick machine sale and push immediate sales before the machine specification is known just to make a sale. Individuals who gain a little knowledge and then steer the entire group to try to go it on their own. Poor planning. People who do not understand the problem they are trying to solve. Inflexibility. Startups more interested in funding or selling their startup than putting in the work it takes to develop a robust platform. Underfunded budgets or lack of appropriate resources. They may have resources, but they're putting the wrong one in. Over-engineering, making projects way too complicated at the beginning. Over-anxious management, putting innovation on a deadline rather than a milestone system. Micro-managing team members. Indecisive and slow-moving corporate structures. Sometimes the personnel are transient in that they may leave and then you get new people in, and it might be 2 years down the line and you have to explain everything or start all over again. Take no prisoners. People trying to save their jobs or win company awards and claiming credit for others' work they do not understand, nor did they do. Uncooperative people who prefer to work alone or in silos. They refuse to share information with their teammates. Trying to fit innovation and numerous iterations into a lean or Six Sigma format from the beginning. This is fine when you get to production, but not for the product development process. Not enough documentation. People who don't take notes, who don't write things down, or think that they're going to remember everything. You cannot treat this process the same way you would an apparel project. Not defining roles and responsibilities. We've seen so many team members step all over one another, or things get dropped. Too many meetings and wishful thinking. Talking about what's going to happen, but not enough elbow grease to make it happen. Changing the goalpost based on anecdotal input from people that have no skin in the game. Talking to third parties rather than team members, and projects just get dropped. Treating innovation as a part-time activity. Innovation is a constant process in a company. It is not innovate when you need new ideas. This is a constant thing. Now, I put together the innovator's journey. Many may find this layout familiar to Joseph Campbell's The Hero's Journey, which Campbell says is the root of every story told on Earth by every culture and every time frame. Our innovator's graph demonstrates the journey of the designer, design team, brand, or startup in building innovation. Once the designer, brand, or team decides to adventure into the unknown and triumphs over the roadblocks and stays the course, sticks to their roadmap, defeats the naysayers, and battles the temptation of accountants and attorneys trying to shortcut the project, and resists buying any stock machine at whatever is irresistible deal being offered, there's usually a transformation of mindset. We will talk more about the product development process and compare and contrast the traditional product development path and the innovative development path in the design track of Fab Design's Learn with Leaders program. We'll go into more detail about the innovator's journey, and we'll take each step and break it down into manageable parts so it's not so overwhelming. Today's challenge to innovation in technical textiles is intellectual property and the new laws that have taken effect in the U.S., where the first to file prevails. Rather than prior to 2015, the patent filer was required to prove inventorship. Patent trolls have sprung up around every corner of the industry, patenting anything that has not been patented before. Patent pirates are rampant at trade shows, and still others with deep pockets browse machine builders' libraries for theoretical applications. Since 2015, the atmosphere in the knitting industry is one of caution and has resulted in pages of NDAs and mutual NDAs just to have simple conversations, interviewing potential collaborators, interviewing technical contractors, and interviewing manufacturing factories. In the US and Europe, the sticky IP issue has created friction and reluctance between potential mentors, engineering contractors, machine builders, machine suppliers, material suppliers, and their customers, the designers, brands, and startups, in regard to intellectual property ownership in the textile industry. Never before have machine builders patented fabrics and products, but they do today. What has compounded this issue is the experience and expectations of working with offshore apparel manufacturing partners and suppliers offering fast, easy, and usually free access to breakthrough products, services, and solutions to effectively compete in the innovation-hungry economy, where it is tolerated that the manufacturing partners copy, show, and distribute the same products ad hoc to every client and add versions of each client's designs to their product lines and markets them as pick-and-make private label house collections. Machine builders, engineers, contractors, academic mentors, material suppliers, and other teachers are not supportive of putting themselves in the position of having their innovative knowledge and expertise drained by designers, brands, and startups, only to see that valuable knowledge become the sole IP of the designers, brands, and startups, which will in turn be immediately fed to the pick-and-make private label house collections on the other side of the world. How many companies visit trade shows and see their own products or close copies on display from companies they've never worked with? Never before has researching prior art and defining at the outset who owns what IP been so important before undertaking a project. Every year, attorneys, grad students, startups, brands, designers, and inventors seek to make and patent knitting technology products that already exist. Or worse yet, they find themselves seeking any knowledge of prior art to dispute a cease and desist because they've already made something someone else is claiming as their intellectual property. In order to build enough products in 3 to 6 month traditional development window, many of the legal search steps are skipped. Products are bought off the trade show floor, pulled from retail stores or Pinterest, and tweaked what they think is enough. The company now thinks they have done their work, maybe gotten an exclusive with the factory, and they own the product. Preliminary patents on design and function are filed on not only the products, but perhaps the manufacturing process by the company. As manufacturer of record, the designers, brands, and startups own and sell the ordered merchandise, and it's not long before the cease and desist letters may come, and as a complete surprise. In traditional apparel development, a designer, brand, or startup may have up to 3 to 6 months invested in a particular design. 1 or 2 products might be affected by a cease and desist, and the company chooses to play the legal odds, make money, and settle out of court. Where in technical textiles, the investment is usually many times that in effort, resources, and would likely involve the entire product and manufacturing platform. The risks for not doing legal search as part of the development process are severe. Other legal risks that might prove extremely severe to technical textiles are health and safety testing, which if not performed or done properly could result in a product recall and multiple potential lawsuits that then affect the entire well-being of the company itself. There are indeed recalls in the apparel world for safety, Consumer Product Safety Commission, labeling, Federal Trade Commission, and copyright or trademark infringement. In Fab Design's Design Track and Learn with Leaders program, we will discuss the stages of product development and where these legal health and safety steps fit into the process for both traditional and technical development projects. Thank you. We look forward to your visits in our other classes in Fab Design's program.